This is video 1 of the go through lesson for worksheet 7.4. For this video, I will cover page 1 and 2. For question 1, I think most of you managed to get it, even though some of you may not notice it. The question is actually asking for work done against frictional force. Many of you just take 8 Newton multiply by 6, which is wrong because 6 here is 6 meter per second is actually for speed and it's not the distance. So if you want to find the work done against the frictional force, what you need to do is you need to apply work done equals to the particular force that you are concerned with multiplied by the parallel distance. So down here, I'm not sure if you notice, because it is running at constant speed, it would mean that the forward and the backward force, which is here, the forward force, and the backward force over here, must be actually balanced. So you can actually deduce that the frictional force is 8 Newton. And to find this particular distance here, the parallel distance, because it is moving at constant speed, and you know that it has been moving for 5 seconds, you can actually find the distance by multiplying the speed to the time, in this case, which is 5 seconds. So if you do this, you will be able to get the work done of 240. Okay, for question 2, those of you who got it wrong, because you simply assume that the loss in gravitational potential energy here would be the gain of kinetic energy here, but you fail to notice that there is actually initial speed at the starting point. So your energy expression actually consists of 3 terms: 1, 2, and 3. Down here, T stands for top and B stands for bottom. So because of this, you have actually you actually need to consider the kinetic energy at the start with an initial speed of 0.65 square plus the mgh with a height of you do not know, right? You need to find the height, and then you equate it with half mv square, where the v stands for the final speed that you are getting. So it should be 7.0 square here. So if you do the substitution and math correctly, you will arrive at an answer of 2.4 meter. Yep. And like I said, down here, some of you, when you see that her speed must be kept below 7.0, some of you change this 7.0 to 6.99. You don't need to do this because in physics, we take the limit like 7.0 here as inclusive. Anyway, if you think about it, 6.99, isn't it 7.0 in 2SF? So actually for physics, whenever you see limits like that, you don't need to just try to minus 0.0001 to it. There's no point. Okay, following that, we have this question whereby question 3a, many of you are able to show that by calculation that the work done by the pushing force, when you multiply by the parallel distance, since the distance is 0, no matter what you multiply, you will get 0 joules at the end. But some of you are struggling to explain without any references to the work done formula. How do I explain that the work done on the wall is 0? So here actually what I'm trying to check is that whether you have the concept whereby work done is basically transfer of energy from one body to another. So in order to prove that there is no transfer of energy from the man to the wall, you simply need to show that the wall doesn't gain any energy. So for example, how do I prove that your father has given you some pocket money? Well, I just need to check whether your left pocket and your right pocket, is there any increase in pocket money, right? If there's no increase in pocket money, meaning that no one has given you money, since money cannot be created or destroyed. So down here, you can simply, down here in the answer, right, we are actually very focused on checking whether you have this concept of if there's no change in the energy store of an object, it means that there must be no energy transfer into the system. So as long in your answer you show me that there is no change, I repeat, what I'm looking out for is whether you can equate the idea that no energy transfer means no change in the store. So this energy store, you need not use the keyword energy store, but you can highlight that there's no change in KE, GPE, or the internal energy, which refer to, which will which is affected by temperature. So this way of answering is actually very good, the one that I'm showing you, because it is very concise. Yeah. Okay, then for finally for question 4, the common mistake is not that you guys are unable to visualize how the context becomes energy conversion. So in the context, it says that a car initially moving at 10 meter per second somehow increase its speed to 16. So many of you are able to tell me that, oh, the initial kinetic energy must gain some energy in order for the kinetic energy to increase. Many of you are able to tell me that, oh, it must come from the energy from an external source, maybe chemical potential energy. But in this case, since we are already thinking of this chemical potential energy as an energy transfer from the engine to the car, we need not write CPE in the formula, because we already take it as the CPE has converted itself to work done and as a result transfer to the car. So because of that, you will have an equation like this. The reason why some of you are getting wrong is because of a math common misconception. So for example, if you let me demonstrate this to you, I would have something like that, whereby U is the initial speed and V is the final speed. So a lot of you are able to tell me that, oh, you want to factorize it and it will become something like this. What happened in the next step is the common mistake, whereby you do this. This is wrong. Okay, the reason why this is wrong is because if you really factorize it properly, you will find that it will get you v square minus u square in the bracket, and this v square minus u square in the bracket is not equals to v minus u. Okay, so if you do your substitution right, you should get 39,000 joules. Okay, I will leave the rest of the question to my next video.